just want to try to give you a framework on this talk. What we're going to be doing today is I want to try to kind of set the stage for you about this company that we work for, a little bit on the project history and requirements, just kind of the inspiration behind the project and how we've gotten to use AJAX-Solr and Solr 4. I'm going to actually try to do a live demo of the site. This site is behind. You can't go to it because you have to be a customer to come to it. It's an online knowledge-based system. And we're going to do a deep dive on the AJAX-Solr framework, and we're going to talk about themes and widgets and some of the challenges that are there behind that. And Koorosh, the technical architect here, is going to be covering that part. I want to mention here that it looks like, wait a second, why is AJAX-Solr way down here at the end? Well, that's just because he's really going to be focusing on those different themes that's right there. But I'm not going to be spending 45 minutes talking about the company I work for or anything like that. Okay. So I work for a company called Synopsys, and they help people design computer chips. So if you had any kind of electrical engineering background, then you would know what Synopsys is. But most of you are Java engineers, and you may not have heard of it. It's actually a company that has $1.8 billion in revenue. And basically all the computer chips that are in your computer or in your phone or anywhere probably use Synopsys in some shape or form in order to be able to build that chip. So the community is basically electrical engineers. It's a very highly technical audience that we actually cater to for this online knowledge-based system. They're very relatively critical, and we try to make it great for them so that they don't call Synopsys when they have a problem, or they can find knowledge on their own, hopefully. And our customer base is the customers themselves, as well as people in the company as well. They use this system a lot themselves in order to be able to find information. So that's going to give you a background. Okay, so SolvNet is basically an online knowledge-based system. So obviously a great potential Lucene and Solr user. I want to give you kind of a little bit of a history. So Synopsys actually had a knowledge-based system before Mosaic. So this is kind of like pre-Netscape kind of days. You could actually send in a query via email, and you would get a result set back, and then you could actually send in the doc code and actually get the information back in an email, right? So that's kind of pretty pioneering. I mean, this is in the early 90s. And then Apache came, right? So a lot of us are very familiar with Apache. We put it up and we put it online. Then Perl and CGI came along down the line, and the rest is history, right? We've iterated through a lot of other different things that were there. We used a lot of like Netscape search and other things like that. And in 2005, what we decided to do was this was not good enough. We could do a lot better. And so we decided, well, let's take a look at Lucene. And we all looked at other things too. We looked at like the Google search appliance, right? Everyone, everyone's familiar with that, right? Just make it look like Google. And we looked at other things too, some other technologies, autonomy, other things like that. And my team is funded out of sales and support. We are not part of the Synopsys IT department. So we have a dedicated engineering team, but that dedicated engineering team also means I don't have a dedicated budget for like $500,000 worth of search software. I can't just go and say, all right, Mr. VP, would you please sign off on this deal? Right? It's not really like that. So because of that, we still looked and evaluated, and we ended up going with Lucene. And so that was back in 2005. And now last year what we did was we recently moved to Solr 4. So, and we ended up using the AJAX-Solr framework to help make our lives a lot easier. So, and that's what we're here to talk to you a little bit about today. So a lot of us really aren't necessarily familiar with front-end stuff. And so we had to become familiar with a lot of that too. So we want to share that. So here's kind of a look at the background of the way our site used to look before we went to Solr. So this was 2005. We did a lot of stuff related to custom tokenization. We have really strange commands with things like pluses in front of it, right, which would normally be an operator. So we did a lot of work to help make that work right for our customer. And we even also built an autocomplete widget using like a Yahoo UI kind of thing, so that in 2008 we could actually add like an autocomplete feature to the site. The thing about all this stuff is it's all relatively complex. So you build one layer on, then you add another, and then pretty soon the code base gets a little bit unwieldy. We had like a separate Lucene area with a separate Tomcat. We used RMI. And we used PDFbox to extract text out of the PDF files and then send that over to Lucene and create the Lucene documents. And so what would happen is on the right side here, if you can imagine the search results, so you do a search, and then on the left side, you would end up with this on the left side, right? And this is not like this really wasn't a facet. What it was you just had to check the box and uncheck the box and then hit the button, right? And then you would search, you'd add the queries up on top. And So it was, each one of these areas was a separate Lucene index that was there. And I mentioned this because this GUI was very, it's not modern, right? I mean, in 2005 when we did it, it was better than the old one, that's for sure, right? But now it's 2012, 2013, and people expect a different, rich internet experience that you can't necessarily get using the technology we have. So on the front end, we were also using JSF, which is pretty much an antiquated framework anyway. So if we were going to redo the front end and do something with the back end, then what were we going to do? Well, the answer is, well, we moved on up to Solr, and then we use this AJAX-Solr framework. Okay, so whenever you rebuild anything like that, what you really want to do is you also want to try to say, if we're going to try to rebuild this, then let's talk to our customer base. We have internal customers too. What are you saying about our GUI, right? And what about the search itself? And it's always the same three things. You always want to make it faster. You always want to make it better, right? And make it more relevant. And oh yeah, please just make it look like Google, right? Can you please use Google, right? And then we'll be okay. And so, okay, well that sounds like an interesting set of requirements, and that's a great goal. So what are we going to do there? From the technical side of the fence, we had this Lucene code base, and that's something that we could potentially leverage, some of the customizations that we already have. But we're going to have to modernize the GUI. There's no way we're going to get around trying to redo JSF with a new, more modern whatever. So why don't we go take a look around and see what's out there? So one of the reasons why we're here today is because of ApacheCon 2010. So that was in Atlanta, for those of you who may have been there or may not. And Eric introduced me here, but Eric did a presentation on rapid prototyping with Solr at the conference. And Chris, who's going to be doing Stump the Chump this afternoon, he did a talk on Solr out of the box. And the slides are still out there if you want to take a look and all that kind of thing. And basically, when I came away from that conference, I came to the realization that Solr could really help us, right? This could really help us with our problems. And this is right off the Solr wiki, all the different things that are there. So that gave me the ability or the breakthrough to say, yes, we really can do this, right? So once again, then the question became, this is back when Solr 3 and Solr 4, Solr 4 was really under fast development when we actually went down this road, right? So the question was going to be, were we going to go to a stable release of like 3.6. whatever, or were we going to go for it and go for Solr 4, right? And this would be trunk code, like not even all the way to alpha or beta, where we're going to take a snapshot and go for it. And we came to the conclusion that, first of all, yeah, let's go Solr. We can have faceting. We can modernize this GUI. We can get rid of all that extra custom code that I talked about. We can get rid of some of that because Solr does things that we didn't do before. And oh yeah, then we'll use Tika too, and we'll use Solr Cell to extract that data out and then get that down into the index, right? And on our website, we have lots of files that actually, like Q&A articles that have attachments. And these attachments may be PDFs, or they may be like extra, all kinds of different MIME types that are out there. Lots of tickle scripts, all kinds of really interesting stuff like that. And we weren't getting all of that stuff. And it makes it much easier to do with Tika. So if you're interested, do take a look at the Tika project. It will really help you. And so then we decided, well, what are we going to do with Solr 4? Are we going to go for it? And the answer is yes, we will, because this spell checker technology and the synonym stuff, the improvements that were there, we decided we were going to go ahead and take the risk, right? So now what I'm going to do is kind of give you an idea of how this thing works, and that's what they'll do is they'll set us up for the deep dive that we're going to talk about when it comes to AJAX-Solr. So this is a screenshot. This is just in case the demo doesn't work, right? It kind of give you a taste there. Okay, so this is the real website live, okay? And I want to mention a couple things before we get here. So I mentioned, yeah, can you just make it look like Google, right? Well, we kind of did. We kind of made it look like Google, right? And I mentioned this because as software developers, we aren't necessarily so good at the nuances of how to make a GUI look great. And I don't have a resource I don't have a UI designer on my staff that can help me with that. So what we did was we went around and we looked around. We did some wireframe mockups and some other things. But you're going to see that it looks a lot like Google in a lot of ways. It's got a white background, okay? It's got blue links, right? It's got green extra information, right? You go look at Bing, you go look at Baidu, right? Go look at Google, right? That's the format. So why don't we just make it look like that? I mean, they have billions of clicks and great A/B tests to determine that this is the best way to make it look. So we ended up going down that road too. So if you're ready to do a new GUI, we could use fancy purple colors and things like that. These are legacy colors, right? If I had to do the site over again right now on that stuff, I'd change it too, right? Keep it familiar, right? So now I'm going to do a quick search here, and I'm going to talk about the facet counts, et cetera. And so I'm going to do a search here on a term, and I mentioned as a side effect of some of the autocomplete stuff, we actually have people that use this website just to remember commands, right? Kind of like a dictionary. Right? So what you can do is you take a look, and just like that, you end up with the word. So if I was going to do a set clock gating, we can see here that the commands appear. And if I do a search separately, there's actually a different type of search that's going on here, and Koorosh will elaborate a little bit more about how there's two nuances to this autocomplete later. And I want to mention briefly here, when I do the search, so I do the search here, and we are on Wi-Fi here, so there could be some issues in terms of timing. But just to give you an idea here, there are different widgets that he is going to be talking about in the talk. We have an area so that people can customize. There are lots of different tools, so they have settings sometimes. They only want to search on a couple of tools, and they come back to that, and they load those settings. We have facet counts by document type right here. And you can see that the numbers are there, even though it may not even be checked, right? So we actually know that the facet count is 2615 here in the documentation zone, but I don't have that one checked, right? But that gives everyone a visual clue that that information is available. I just need to click the box and send the query back. And since we're using AJAX, we're sending less data across, right? We're going to have to repaint the page and redisplay all the stuff that's there. And I want to go down here just briefly. We have all kinds of different tools that are in this very large company called Synopsys. But you can click on these, and what happens is that you end up narrowing the results. So now I'm down to one, right? Because there's only one in Simplify Pro related to set clock gating, right? And if I click that facet count, I'm like, I really care about Simplify FPGA as well. That's a sister product, and then I end up with the search results. So I want to mention here that you can search by date. We have the ability to. Very few people actually do this, but you could hide the summary if you want to. And we have hit highlighting technology and all of the things that I'm sure a lot of you are very familiar with here in the product. And you can resort, et cetera. And we have a pagination widget so that you can come down here to the fifth result and you end up at 41, 50, et cetera. And Koorosh is going to talk about a little bit more about that. And we also have these attachments that you see right there in the red, right? So that's an example of a lot of different things that have been hooked in there that we're actually indexing. And we highlight it and hit it, et cetera. OK, so there's a quick demo, and it works pretty fast. It's pretty good. I mean, it's pretty amazing how well it actually really does work. And it's very reliable. And so just briefly, I want to briefly talk about, basically, this is why we went to AJAX-Solr and Solr 4, is that you get the faceting capability, and you have these other things like autocomplete, spell check, did you mean, synonym list, all that stuff. And we can do deeper search, and we can had a better hit highlighter too. So I want to briefly mention a couple things related to AJAX-Solr that are considerations before you actually see what the framework that Koorosh is going to elaborate on. Is that one of the issues that like I mentioned before, is that we have limited resources. I don't have a GUI designer on staff, so I'm going to try to leverage a framework to help me with that. And that's why we chose AJAX-Solr. And we do know some JavaScript, but we're not JavaScript ninjas in the team. We're not really front-end people so much. So that's another thing that you might want to consider when you consider AJAX-Solr. And the fact that nowadays, it's a given that you have to have a rich UI. You have to have autocomplete. These faceting counts and all those kinds of things they're really assumptions now. They're not eye candy anymore. They're things that you pretty much have to have on your site. And AJAX-Solr can help you with all of that. Just briefly here, when Koorosh gets up or whatever like that, we're going to talk about all these widget frameworks and the ones that we've developed. I want to mention that AJAX-Solr is based on JSON, so you can use jQuery and you send the data back via JSON. So it's modern, I would say, and that's important, and that's sustainable long term. I don't want to go to a technology I don't know is going to be necessarily around in the next few years. There are challenges around session management, and also the AJAX-Solr, it's not a Lucene mailing list. Right? There's not nearly as many people that are actually using this framework necessarily. But the community's OK. It's a Google group. So you're OK. And we'll also talk about proxy. All right, so now I'm going to hand the mic off to Koorosh, and we can get started on the deep dive related to the framework. So thank you.
Hello, everyone. I hope you're still awake and enjoying the talk. So before I start, I wanted to ask a question from you guys. How many of you consider yourself a JavaScript expert? Have you done programming with jQuery and those sort of? Okay, very good. Another thing, what I want before I start the talk, I want to explain some of the stuff here. Is the goal here? I want to go over AJAX-Solr, describe what the framework is, get you to understand how it works, give you some best practices, and also discuss some of the challenges and interesting things we did with it. So once you understand that, you first know how it works. Second, you see if this is something that interests you and also matches your use cases. Before I get into AJAX-Solr, I want to describe what our architecture is as far as our search application is involved. So what happens is user, when it comes to the search page, the page gets loaded from our web application, and then through the proxy, and the user types in their query. The query goes back to this Solr search server. When it executes, the response comes back again through the proxy, back to the browser, and everything gets done over there. In our case, we ended up having our indexes happening also on the same box. We didn't have a need for separating out on a separate box, and it meets our need at this stage. Now, why we did decide AJAX-Solr? What was it going on? As Troy talked about the requirements, the GUI is very dynamic. We have faceting going on. We have autocomplete. And what we had was we wanted to get to some place that the traffic between the search Solr and the client is at the minimum, because it doesn't matter how fast your search runs on the Solr server, the whole end-to-end is the issue. The other thing that you notice that we wanted to keep the amount of refresh on the page to the minimum. And the number of mouse clicks was important too. We wanted to make the GUI very dynamic, where one click does something for you. Whereas before it was like form-based operation where you type in your query and click all the selection you wanted and click search, and that would run. That wasn't acceptable anymore. Also, finally, we wanted something that's very intuitive for the user. In the past, what we had was we had actually help for our search. User had to go and look at the help, figure out what's going on. That didn't make sense. We wanted to have a search that's obvious from start to work with. Now, AJAX-Solr, if you go to their wiki page, they say it's a JavaScript framework which is running on top of a JavaScript library, like something like jQuery, and it interfaces with Solr server and executes the search and comes back and gives you the result. Now, what is the AJAX-Solr setup as? The architecture is very object-oriented. They are using MVC, a well-established design pattern for the GUI. And it's what we did, we ended up using jQuery as the JavaScript library. It also supports, you can write your, extend it to use other libraries, but we ended up using jQuery. Now, the main components of this framework is the manager, parameters, widgets, and theming. And I'm going to get into that later on. So before we get into the detail of the AJAX-Solr, let's look at it from a black box point of view. How does it look like? So here we have a snapshot of a query that Troy ran, and that's what the result comes back. What's really happening? So if you go to the browser, when the user goes to the search page, the index.jsp gets loaded from the web application server on the browser. And when the query runs, a request in the form of REST request goes to the Solr server. And here you see Solr select, and the query value is set to the clock tree power and gets executed by the Solr server. The response comes back in the form of JSON. That's standard Solr protocol, and gets displayed on the browser. This is the example of the JSON return result. You see that for the header, you have the time it's spent running the query. Here is the parameter of the query value, the string, and some of the other stuff that's being set. This section shows you the documents that came back. In this case, we have an ID, title, product, and a teaser section. The next part is the faceting part of the search. This is the highlighter section where you see the highlighted text. And finally, there is the spell checker section. In this case, we don't have anything. Now, what happens in case of autocomplete when the user types in? What happens here is there's a different AJAX call going back to the server, Solr terms. We are using the term component. This is the, we are using the regression parameter for the term. And you see this dot star, these are wildcard because we are trying to address the issue of matching the text in the middle, at the beginning or at the end. More on that topic. And the result comes back in the AJAX JSON. And this is all it is. This is the result that comes back. Now let's get into the actual AJAX-Solr. How is it put together? As I said, there is 4 components to this framework. There is the widget, that where the user talks to, interacts with. The request goes from the widget to the manager, and then from there gets as an AJAX call, goes back to the Solr server. The return result via the manager gets stored in the ParameterStore, that's the model, and then from there the widget reads that and displays it back to the user. Let's talk about the manager. How do you instantiate the manager? So it's basically a simple JavaScript call, and it's being, this is how it's done. Now, I want to point you to this name AJAX-Solr. This is the namespace AJAX-Solr uses. So for those who know with the JavaScript namespace, the best practice is use a single namespace so that you don't pollute the global area, and stick with that and put every object or parameters at that level so everything kept clean and nice. Now, Solr URL is the parameter you pass to the manager to tell it where to go to for the Solr search. So in this case, this is the URL for our search, Solr search. Now, when we are talking about the manager, I want to raise the issue of talking directly to the Solr search versus through the proxy. You guys know we live in the real world. Ideally, we don't have to put a proxy in front of a Solr server to keep it from people accessing it inappropriately. With Solr server, you can theoretically send a request for it to delete the collection, restart the indexing, those sort of things. You don't want somebody from outside actually do those sort of things to you. So, and we already had a proxy server set up for our web application. It was a matter of just configuring it so it would also cover the Solr server. And only limit the request to those that are allowed and nothing else. Now let's talk about the manager lifecycle. Here, I'm going to show this whole thing through using UML sequence diagram. I'm finding that is very useful to explaining what the flow of the execution is. So when it comes to the manager, the first thing that happens, the index page gets loaded on browser, the manager gets instantiated. After that, the parameter store gets instantiated, and a pointer to that is passed on to the manager. Then for each of the widgets, they are being instantiated. Again, a pointer for the widgets are stored with the manager. Then after that, the init method of the manager gets invoked. And what that does, it calls the init method of the parameter store and all the widgets. And finally, this is a more like an optional thing. Do request on the manager gets executed. And what that does is first makes a call to the before request for all the widgets, makes a AJAX callback, which in this case would run actually the search query. And finally, the after request gets executed for all the widgets. It all depends what you want to do. If, let's say, you go to the load up your search page and there is no query, you have the option of, let's say, run a WildStar query on your whole collection and just populate the facet part of it. Now let's talk about the ParameterStore component. What ParameterStore's job is to hold different query parameters as well as the return result. There are a bunch of methods offered by this component to set and get things. Here in this example, I'm setting the value of the queue to the well-known WildStar query. There are a bunch of implementation of this class, which is listed here. Here I want to talk about ParameterHashStore and why we ended up using it. Before I get into describing that, I wanted to explain some of the requirements that this implementation helped us to address. One thing was bookmarking. One of the requirements we had when it came with this implementation was we wanted user be able to save different queries. And with AJAX by application in general, that's not easy. So we had to implement it so people can save different queries for later retrieval. Also, back button is another challenge. What happens is if you don't implement it and take care of it specifically, if you click back button on your search page, even if after you ran, let's say, 3 or 4 searches, it actually takes you out of the search page back to the previous page you came from. That was another consideration. Also remember, people can go back and forth. You have to watch out for that scenario. URL masking. As Troy mentioned, our user base are very technical people. When they see something, especially with the URL, and there are get parameters in there, they start playing with it. And the last thing you want to do is somebody playing it and push return and they get an error. And on our back server, we see a bunch of errors in the log file and we're wondering what's going on. And then it turns out somebody was playing error. To keep them from doing that, we try to rewrite the get parameters so it doesn't look something that they get tempted to play with. So what is the ParameterHashStore does to help us to address these issues? One of the things it does is offers a method called save. So before submitting the request, it can save the state of your search in a stack so you can retrieve it at a later stage. For example, for the purpose of back button. And to make that work, you have to actually first expose those parameters that you want to be saved in the stack. That's what this expose method is doing. Now let's talk about widgets. Widgets is, in my opinion, the most interesting part of this framework. What's the widget in context of GUI? When people talk about widgets, is a GUI component that a user interacts with, both inputs to it and gets information out of it, like displays. AJAX-Solr has done a very good job of setting up a very object-oriented structure. So in this case, we start with, it defines the abstract widget that is being extended by all the other widgets. And there are multiple derived widgets here. We have faceting, TextWidgets, and spellchecker, and others that I'm going to cover in more detail. You wonder where are the widgets being used. Look at the page. All the red boxes show you a widget. Okay? Now, basically, the JavaScript, here's, you see a template that shows the JavaScript for the abstract widget. What is happening here at the very top, abstract widget extending the AJAX-Solr class, which is, when you look at it, it's just an empty class, nothing interesting. But it's here what we have, we are defining a class that has two attributes of ID and target. ID is used to uniquely identify that widget. The target is pointing to the DOM object for, in this case, jQuery to play with. The init method, as we talked about, it gets, does some initialization work for the widget. Before and after request get called. Just reminder, here is the flow, and here is the init before and after methods of the widget being called. And usually what happens is a query request gets started by do request of the manager, and that's how the whole flow works. Now let's talk about the text widget. What is the text widget? The job of the text widget is just handle the interaction with the user as far as typing the query and capturing the query request and passing on to the manager. So it's basically, its job is just populate the queue parameter of the query. There are two implementations. One is a text widget, which is a very simple implementation. There is TermWidget, which was contributed by the community. You know, David Smiley, he was the contributor for this widget. And we are actually used that to, and extended that. So Autocomplete TermWidget, basically, here is that widget. Here is examples of how it's being used in two different modes, one as a single mode. Notice that the terms being completed could be in the middle, at the beginning, and at the end. For the two term or more, it actually functions as a prefix. The template for it looks like very similar to AbstractWidget. Basically, I'm going to use that to describe all the other widgets. So there are additional attributes defined here. During the init, here is where I want you to start thinking when you implementing a widget. What are the things that go into different phases? Like during the init, in the case of autocomplete widget, you want to register handlers for the key events, like key down events, or carriage return. For carriage return, for example, you want to actually submit the request for search. And autocomplete is that's what's happening. For the before request method, what's happening in there? As you notice when we ran the search, we grayed out the input box. What we were worried about, if the search takes more than 1 or 2 minutes, 2 seconds, people start typing into the box. We didn't want that happening. So this is where we disable the input box. And after request is when we enable it again. So that's how the framework lets you, force you to put things in the right location, structures. Now, let's talk about the autocomplete aspect. As I said, that there is, we handle the autocomplete for the first term differently than the second term. For the first term, we are using terms complete part of the Solr. For the second term, we use the facet prefix. And the good thing about the facet prefix, it also uses a facet filter. So it nicely only shows you those autocomplete terms that you want to applicable to those terms that you have, those facets that you have selected. Now, another thing I want to talk about is analytics. So you are aware of there's different talks on analytics here at the conference. this is the place, this is the widget we use to capture certain data as part of the analytics. For example, the query that the search run is one of the things we capture. Also, we capture some information around that autocomplete. Now, ResultWidget. This widget is basically obviously shows back the result of the search to the user. If you remember, Troy mentioned that we are also a result can have attachments associated with it. So on the back end, the way we have done this thing is when we index a document and an attachment, we index it as a single record in the Solr. And the result that comes back, we have to also handle it so it comes out looking like there is a context, shows everything in the context. So for example, here there is highlighting happening in the attachment, but we require to show the parent article that this attachment associated with. That helps the user to understand what's going on. Otherwise, if they see just the attachment, they may not get the whole picture.
The document 3, both the where it says 3 and the attachment are one
record. Yes.
One record.
Mm-hmm. So here is the template for the result widget. What's happening during the init? One of the things, if you remember, I said this is the place to do some setup, like putting the handlers for certain things. If you remember, Troy showed you you can get rid of the summary section or expand it. That's where the handler gets registered. Before request, what's happening is you saw the turning gear that was going on while the search was going on. This is when that image gets shown, and when the result comes back, obviously that gets replaced with the actual result. Now, more on the result widget. One topic, again, I go back to the analytics. This is the time that we record how many results came back from the query, what facets were set, and what type of content they were, the users narrowed their search on. PagerWidgets. Again, at the bottom of the page, you saw this thing where the user can click on different pages, so they basically move around. And our requirement, our implementation is different than the one that AJAX-Solr provides you out of the box. Our requirement stated that we only show 10 pages per search. And if you hit the last page, in this case, number 10, it would pan it to the middle of the pager result icon. The template for this widget is pretty simple. Most of the work is done in the after request, and this mostly has to do with calculation of the number and position of the page. Facet widget. This was the most, I would say, interesting and the one that we used extensively. We have 2 instances of it where we use it to narrow the content type. Or for the product, as you see, we have a scroll bar here and pick list here. And there are these extra links that basically we had to add so the user can easily get rid of their facets if they needed to. Then in the template, going back here is during the initialization, we are setting up some field parameters for the faceting. Most of the work is happening in the after request method where you register the handlers. Let's say you click on one of the facets. That's when the handler for unclick gets registered. And these are methods that are used inside this widget. Theme. Theme has to do with mostly presentation layer. What's the goal of the theme? The goal of the theme is to separate the presentation layer from the rest of the code. So for example, in the facet widget, if we are trying to create a link and register a handler with it, we make a call to this method, and in the theme, this method is being defined. So that way you don't have to look and search for where the actual HTML being generated. Now, we covered the basics of the AJAX-Solr, but there is additional requirements that we needed to address. One of the things that when we implemented this thing, we realized we are dealing with the search application not in its own isolated context. It has to interface with third-party and back-end applications. Example of third-party was, as I said, analytics service that we use. In our case, we use Omniture. There's Google Analytics too. Survey, for example, we would use that too. The backend, we have application that shows to the user the recent searches per session. So we needed to somehow capture that information, and the way we did that is basically by AJAX call back in to the backend server and basically saving it in the user's session. And for personalization, that another AJAX call to go to the and save that information in the database. Error handler is something that people don't realize or pay attention much because it's not part of the main function of the application. With JavaScript and especially AJAX applications, you have to pay close attention to it. So what happens is if you don't handle it, what the browser doesn't react to anything. It looks as if nothing is happening. Whereas in the backend, there is a 500 error, HTTP errors coming back from the server. So we had to cache that and accordingly treat that case and show appropriate information to the user. Also, we wanted to log that information in the backend server. That's an important concept to remember because we don't want getting a call from the user saying, okay, your application is broken. We want to see that in the backend and see what's going on. Now, security. As I discussed, we had a proxy server sitting between the browser and the server to cache an appropriate request. But we also had the requirements around role-based requests. So as Troy mentioned, there is employees and customers accessing the search application. So for employee, we wanted to expose certain data, whereas customers, we wanted to limit them to certain things. And how do we handle that? It's not something that AJAX-Solr can handle. It's the browser. It's not on the browser side. We have to do it on the back end. So we introduced some, implemented a filter on the server which looked at the request, and based on the role that the user has, we allowed it or not. Session management. This is a problem that we realized maybe later during the project. What happened was application was working fine, but we realized that if a user leaves the browser for a while and the session expires, what happens? They come in and type in and they expect autocomplete to work, and the autocomplete wasn't working. And we were wondering what's going on. It turned out what happened, the session expired, the request was, AJAX request sent to the backend, and session timeout error comes back, and well, it wasn't handling it. And what we did, our solution was, as they type, we realized the session expired, we redirect them to login page. Now, debugging. With JavaScript, you need to learn how to debug JavaScript. With Java, you have your IDE to work with. With JavaScript, you basically have to use your browser as your IDE. You have to learn what debugging tools are available. For Firefox, there's Firebug. For Chrome, there's a whole set of developer tools. IE has it too. So you need to learn the debugging tools that the browser offers to you. Also, when it comes to looking at the communication with the server and the browser, you need to understand how this JSON format is and understand how it works and actually send requests to it and play with it. A few times, I had to basically bypass AJAX-Solr framework and directly talk to the server and see what's going on. And that was very valuable. Performance. This is a topic that usually happens, people come to at the very end of the project because they think, okay, we can fine tune it. Whereas I argue you need to look at it at the early on, even at the design stage. I give you an example. What we had a situation because the size of the data and traffic going from the server to the browser could impact the performance. You don't want to send, let's say, the whole article to the browser and parse and just show the first few lines for summary. You want to somehow just limit the result to that summary. And the way we addressed it, we introduced a field in our Solr schema teaser that already at index time takes care of, captures the first few lines, and that's the only thing it sends to the browser. This is something that saved a huge amount of time. Actually, it addressed all the first 3 items here. Also remember to use utilities to compress your JavaScript. Yahoo has a utility that does that for you. Keep that in mind, as well as CSS. When it comes, if you are using proxy, which we did anyway, and you use the proxy's caching functionality to cache JavaScript and CSS. That's another thing to keep in mind. Now, housekeeping. As AJAX-Solr states, they are JavaScript library agnostic. In our case, jQuery and jQuery UI. You have to keep on top of it and keep it up to date. What happened in few cases, we found out, okay, we were playing with a widget and it wasn't working properly. We found that, oh, okay, we had to upgrade our jQuery to the later version working. Also, browser compatibility is a big issue. You have to keep testing and finding out if the latest browser works with it. For example, we already at the onset, we knew i6 is not going to cut it for us. We are finding out i10 has some issues. We track it down that the later jQuery addresses it. So that's something to keep an eye on. Also, browser plugins could cause headaches. We found out that a plugin was interfering with the function of the third-party analytic tool, in this case Omniture, and causing that thing to fail. And what happened, that failure cascaded all the way to the AJAX-Solr, and the application looked broken. And that's something to watch out for. Now, in conclusion, I want to review what we talked about. We talked about the requirements. We talked about the framework AJAX-Solr, and I talked about some of the best practices, some of the challenges, and some of the possibilities that we had with the AJAX-Solr framework. Finally, I want to conclude by acknowledging James McKinney, the creator of AJAX-Solr, Lucene and Solr community as a whole that made this whole search application possible, and our SolvNet team that obviously without them, this thing wouldn't come about. Now, here are some of the links. The first one points you to the Solr wiki for AJAX-Solr, and the second one points you to the Google group. I'm finding out the application is relatively stable, so I don't see that many activities on the group, but still James is very active in responding to questions. Okay, the question is, how did we address the mangling of the URL? If you look at the ParameterHashStore method, or not method, the object, it has a discussion on that. There is a save method associated with it. that you go, that you rewrite it, and what you do is the parameters, you can map the value, name of the parameters in that object. So they look at the save method, and they discuss it in the website. The question is about the difference between spellchecker and did you mean? Okay, it depends on how you, what Solr framework. Yeah. Tell the truth, I'm trying hard to imagine what the difference is. They're pretty much the same. It's how you invoke the backend server, and what method you use for that. The spellchecker is concept of looking up some terms based on the query and trying to match the ones that are related to it. Daniel, so the question is, how does it handle pivot faceting versus regular faceting? And it doesn't handle pivot faceting. It's what it is it provides you a basic facet function that you saw. And if you want to implement pivot faceting, we actually looked into that. We ended up writing a customized code to handle that. We are not using real true pivoting. As you're thinking of, like, click here, it's a hierarchy that you drill down. It doesn't do that. I mean, you can extend it and customize it. It's up to you. That's the flexibility. Okay, the question is what sort of feedback we are getting with the new GUI that we are offering. Maybe Troy can better answer it. Oh.
So when it comes to feedback, I always use the concept of if you hear nothing, then that's a good thing, right? And we heard very little. I mean, you know, we hear feedback about how it seems faster and it looks more modern, that kind of thing. There was a couple of features that we did take away as part of the site that people really weren't using, and you always get like an outlier kind of scenario where somebody was using that weird function. If you give them the secret, the secret way to still do a date range query or something like that, then they're okay. So that was something that we kind of took away from the GUI, that nobody was really using it, and because you want to start with the funnel being large and then move down from there. That's kind of an example of So overall, great. People are happy. Yeah, the logic behind that. So the answer to that is that there are some outlier cases where it can take a few seconds, and one of the issues, it's generally pretty fast. The issue around like hit highlighting and things like that can throw stuff for a loop. So if you have like a lot of attachments, there's an outlier use case for a particular set of documents that have a bunch of PDFs that are in there. And so what happens is that particular, if you search on this command called rmgen, because of that, it could take a while, it could take a couple seconds, and that's why we actually do the gray out.
Yeah, a little bit more on that is we found out the actual search runs quite fast. What it is, as maybe Troy mentioned it or not, some of our documents that being indexed is 700 pages long. And what happens is the highlighter, when it starts highlighting that thing, it has to go through that 700 pages long, and that's causing the performance hit. Stating the question is on this, when it came to doing access control based on role, how did that happen? Obviously, you don't want to do it on the client side. That's where you don't trust that client. What we did was wrote a filter on the Tomcat side, sitting on top of the Solr. So before the query gets to the Solr, we looked at the query, and we also know what the user role is. Based on that, we actually parse the parameters being passed to the Solr, and if they were, let's say, looking at a field or a content type that they are not allowed, we just drop it. Or say actually access denied, actually.